Hey guys, welcome to the mock review packet day 1 video. So this is just for sequences, series, and binomial theorem. There'll be another video up with all of the function attribute stuff. I'm sorry I don't sound as excited as usual. This is a really long packet, so we're gonna have to work through it together and it will be very great, I promise. But I don't sound as convincing as usual, so I apologize for that. Anyways, this is the answer key. Just a reminder, as you probably know, any formula you need is gonna be on the front page of this packet. So just in case you ever need any reminders, remember that on the front of this packet is everything that we are going to need. So let's get started. So we start with arithmetic sequences. An arithmetic sequence is given by 5, 8, 11, etc. Again, if you're looking for your notes, remember that it corresponds to lesson 1.1 and 1.3. So write down the value of D. As we know, the D represents our common difference. So how do we get from there to there? We add 3 each time. Officially, we could take 8 minus 5. But we get our common difference is 3. Then it asks us to find the U sub 100, so the 100th term, and then the sum of the first 100 terms. So as a reminder, U 100, that means we're going to use the formula UN equals U1 plus N minus 1 times D. So let me look. My first term is 5 plus N minus 1. I'm looking for the 100th term, so 100 minus 1 times D, which is my common difference. I'm going to be doing this one alongside you guys, so I might be a little bit slower than usual. I apologize. I'm going to type in 5 plus 100 minus 1 is 99 times 3. I'm just going to do it like that because I'm lazy. So I got 302 as my first one. Once again, as I said, I'm doing this alongside you guys. Normally I do it first, but today I didn't want to. I'm just going to go for it. So I might make some more mistakes than usual, so please feel free to call me out, and we will adjust that if I need to. So this next one is the sum of the first 100 terms. The formula for the sum is N over 2 times 2U1 plus N minus 1 times D. That was really messy. I hope that sort of makes sense, but we have N over 2, which is 100 over 2 times the first term, which is 5, plus N minus 1, which is 100 minus 1 times D. Oops, I can fill in something for D. So D equals 3. So 100 minus 1 times 3. That, if I plug it into my calculator, I'm going to simplify as I go. 100 divided by 2 is 50 times 10 plus 100 minus 1 is 99 times 3. That gives me 15,350. I actually did the first couple. I'm going to double check to make sure I'm on the right track. I didn't even multiply that together because I was lazy, so good. That looks right to me. Good. Next question. Given that UN equals 1,502, find the value of N. So this is where it's really helpful to write out what we know. So here we know that UN equals 1502. We know that the first term is 5. We know that the common difference is 3. But we don't know N. So we can fill in around this formula given what we know and what we don't, and then solve. So we know that UN equals 1,502. My first term is 5 plus N minus 1 times D is 3. Next, I'm going to distribute this 3 to both of my terms to solve. So I have 1,502 equals 5 plus 3N minus 3. I'm going to combine my like terms. So I can combine 5 and negative 3. I'm going to say 1,502 equals 3N plus 2 because 5 minus 3 is 2. I'm going to subtract 2 from both sides. So I have 1,500 equals 3N. Going up there, divide both sides by 3. N equals 500. And I was being a little stupid before, and I tried to put it into the calculator and scroll with the table. You could solve it that way, but I got to scroll number 250, and I got pretty bored. So just a reminder that this is another really good and faster way to solve it, is finding out what we know and what we don't, and then just leaving N blank and solving for N. Good. So the third term in the expansion of x plus k to the 8th power is 63x to the 6th. Find the possible values of k. Okay, so this is actually a really tricky one. I really like this question. Definitely a very external assessment-y kind of question. But so I'm going to write out the first 3 terms because it tells us that we're only dealing with the first 3 terms. And I know that this is going to go x to the 8th, x to the 7th, x to the 6th. Once again, this is a term I'm focusing on. And it tells us that that term number is 63. So we know we have our x to the 6th, but what goes into that 63? Well, first of all, we know we have our coefficients from Pascal's triangle. That's one thing. The next thing that goes into there is my second term, which in this case is k. So if I were going to write this out again, I would have my coefficient from Pascal's triangle, and then x to the 6th, which we know, and then k to the what? We need to know what power k would be to. So I know that my exponents should add up to 8. So 6 plus blank should equal 8. So if I'm solving for that blank, we know that that's going to equal 2. So we know we're going to end up with k to the 2nd power. So that's good to know. So now we know that in order to get 63 from this third term, I'm going to take my number from Pascal's triangle. I'm going to try and color code. I did this badly. But anyways, Pascal's triangle times, what do we know? K to the 2nd. Because 6 plus 2 will give me my 8 total. So times k to the 2nd will equal 63. Because the other way we could do it, I know I keep saying that they add up to 8. We could say k to the 0, k to the 1, k to the 2. And that's another good way to check that we want to square k. So now I need to think about the Pascal's triangle number, which I wrote in yellow. So you guys are going to have to write out the triangle, but I did this earlier because I was showing someone how to do it, so very exciting for me. So remember that we're counting down to the 8th row. 1, 2, 3, 4, 5, 6, 7, 8. I'm dealing with this row, and I am looking for the 1, 2, 3 third term. So 1, 2, 3, I see that my coefficient I'm going to take from Pascal's triangle is number 29. So I'm going to fill that into my little algebraic expression I have going here. So we have 29k squared equals 63. To solve for that, I'm going to divide both sides by 29 to get the k squared by itself. My calculator just turned off, so that was unfortunate. But we have 63 divided by 29. That gives me, that's just what that is. So I have k squared equals 63 over 29. How do I undo a square? I'm going to take the square root of both sides. And so k equals the square root of 63 divided by 29. And that gives me 1.47391. I would recommend going to about 2 significant figures. I think that's the external assessment, but I'm going to write out everything because I like to do that. I had another really good question earlier that was about why does it say find the possible values of k if there's only one value? It's because technically when you take the square root of something, you're taking, the answer is plus or minus that, because if you took a negative 1.473 times a negative 1.473, you'd also get k. But that's not super important, but just so you know that it's technically plus or minus 1.47391, that's something to be aware of too. So that's why it says find the possible values. But it's okay if you just write k equals 1.47391. That also makes sense. Good, so that was actually a really cool application of a binomial expansion problem. Now we're back to our normal one. So we have consider the expansion of 2x plus 3 to the 8th power. Write down the number of terms in this expression. We know that the number of terms is equal to the n plus 1. So my n here is 8. It's to the 8th power. I know that there's going to be 9 terms. So if we don't remember that it's one more, the number of terms is one more than our exponent, you can always look at Pascal's triangle and then look at the 8th row and see that there are 9 numbers there and you know you have 9 terms. Good, so that's part 1. Find the term in x cubed. So this is kind of sad, but basically what we're going to have to do is solve it all the way out and then figure out what the x to the 3rd term is. So set it up all the way. You don't have to simplify any of them except for the x to the 3rd term. So I'm going to start with x to the 8th plus, I'm going to write out my 9 terms first, 3, 4, 5, 6, 7, 8, 9, x to the 8th, x to the 7th, x to the 6th, x to the 5th, x to the 4th, x to the 3, 2, 1, 0. Okay, good. I'm going to stop at x to the 3rd just because I really don't want to have to solve any farther than that. So now I'm going to look at Pascal's triangle, once again the 8th row. So I'm going to do 1, and then the next coefficient is 8, 29, 56, 70, and back on this side it's another 56. Good. And lastly, I have my second term, which we see here is plus 3 to the 8th. Oh man, and this was 2x plus. That really blows, doesn't it? All right, well, I'll do that later. So we have 3 to the 0, 3 to the 1, 3 to the 2, 3 to the 3rd, 3 to the 4th, 3 to the 5th. Good. Now, as some of you may have noticed, I forgot something earlier, and that's because my first term is 2x. So that means I'm technically taking 2x to the 8th. I have to basically distribute that exponent to be 2 to the 8th, x to the 8th. So anytime I see something with an x to the 8th power, I also have to take my 2 to that power. So this one would be 2 to the 8th, this one's 2 to the 7th, 2 to the 6th, I don't even know if you can see that, 2 to the 5th, 2 to the 4th, and 2 to the 3rd. Remember that the 2 to the 3rd is the one I care about, so we're going to really focus in on this term. But just so we know, let's double check to make sure I did this right too. So I have 3 to the 5th and x to the 3rd, so 5 plus 3 is 8, so I know that my exponents add up, which is great. And now I can simplify just this term. So let's do that together. So we know that it's going to be x to the 3rd because that's the term I'm looking for, and it tells me right up here. I have x to the 3rd. Now I'm going to take 56 times 3 to the 5th power times, what's next? 2 to the 3rd. That gives me an a coefficient of 108,864. So that's what I got. Once again, I forgot a bunch of stuff. I think that should be right. If you have any questions about it, let me know. But that's 108,864. Good. Now we're back to another arithmetic sequence question. So we have that the first term equals 2. This is the second term. The third term equals 8. So we're missing one. So the first question is to find the common difference. There's multiple ways we can do this. The first way, I know I add my common difference one time, add it 2 times. So I could write an equation that says 2 plus 2 common differences, common difference 1, common difference 2, equals 8. Subtract 2 from both sides. 2d equals 6. Divide by 2, divide by 2. The common difference equals 3. That's one way. Another way you can do it is just say, what's the difference between 8 and 2? That gives us 6. 6 divided by the 2 spaces between is also 3. So if you didn't want to set up an algebraic equation, you could do it that way, but just know that you actually did the algebraic equation in your head. So you're just kind of skipping a step. So I would stick to this way. Good. Moving on. This one asks us to find the 20th term. We're running out of colors to write in, so we have the 20th term. So once again, we have the formula un equals u1 plus n minus 1 times d. My first term is going to be 2, so I have u20 equals 2 plus n minus 1. So I know that n is going to equal 20. 20 minus 1 times my common difference of 3. So if I'm going to put that into my calculator, I have 2 plus 20 minus 1 is 19 times 3. That gives me 59. So my 20th term is going to be 59. This one asks me to find the sum of the first 20 digits. Once again, my formula is going to be n over 2 times u1 plus n minus 1 times d. Filling in everything I know, I have 20 over 2 times my first term, which is 2, plus n, which is 20, minus 1, times our common difference of 3. Ooh, I forgot to close my parentheses. There we go. So we have 15 times, 2 times 2 is 4, plus n minus 1, 20 minus 1, which is 19, times 3. So you get 15, oh, wow, 20 divided by 2 is most definitely 10 and not 15. I'm glad I caught that before I put that into my calculator. This is why simplifying first is dangerous. So we have 20 times 4 plus, I got 610. We're just going to leave it at that. So if that's wrong, let me know. But so we have 10 times 4 plus whatever 19 times 3 is. So that should be 610 for the 20th, sum of the first 20 terms. Good. Once again, if you have any questions, come talk to me or Miss Avera. Moving on, we have consider the expansion x to, oh no, x plus 3 to the 10th power. This is a lot. All right, we're going to start it. So part A, very nice. Write down the number of terms in this expansion. So like once again, we always have n plus 1 terms. This one's running out of ink, so I'm going to stick to blue, which is my favorite color anyway. N plus 1 terms. So we have 10 plus 1 equals 11 terms. So this is the number we're looking for. This is a lot, so I'm going to write out my 11 blanks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Once again, this time I'm actually lucky because it is just x to the 10th, so I'm going to start with that. X to the 10th, x to the 9th, the 8th, 7th, 6th, 5th, 4th, 3rd, 2nd, 1st, and x to the 0. I am focusing once again on the x to the 3rd term, so I don't really know what's going on, why they're using that term so much, but that's where we're looking. So I also need to take care of my second term, which is 3 to the whatever power, but I think first we should take care of Pascal's triangle. So here I'm going to put up my triangle again. Unfortunately, I only go to the 8th row. So this is the 8th row, so bear with me as I calculate the 9th row. So we go 1, 9, oh lordy, 29 plus 8 will give me 37. 29 plus 56 will give me 85. That's 126. And lucky for me, Pascal's triangle is symmetric, so I don't actually have to add anything else. So we have 126, 85, 37, 9, 1. Good, that's the 9th row. Last row, 10th row, we have 1, 10, 37 plus 9 is 46. 37 plus 85 is 122. 85 plus 1 plus 126 is 211. 126 plus 126, that gives me 252. And we're back to the symmetric part. So 211, 122, 46, 10, and 1. So now we are looking at this row of Pascal's triangle, and that's what I will use to fill in my Pascal's coefficients. So I'm going to write in green. So we want 1, 10, 46, 122, 211, 252, 211, 122, that's the important one, 46, 10, and 1. So I didn't plan out my space super well. I'm not going to lie. I apologize for that. This one was 122, remember? I know it's kind of hard to see, but that was a 122. Good. So we did Pascal's triangle. What are we missing? My second term, 3 to the 10th power. I'm going to do this one in purple. The 3, my second term. So remember, starting over here, I would do 3 to the 0. I could go all the way over. That sounds like a lot. So I have x to the 3rd. I want to get to the 10th power. I'm going to have 3 to the what power so that I can get to 10. So I know that 10 minus 3 is 7. So I know it's going to be 3 to the 7th power. So I have 122 times 3 to the 7th power times x cubed. So let me do that in my calculator. I have 122 times 3 to the 7th power. Oh, lordy. That gives me 266,814 x cubed, which I will write now in Packers colors, just for everyone in the room, because I know we need to do that. So we have 266,814 x to the 3rd, and this is going to be my answer. So 2 things on these. When it says find the term containing x third, I know it's annoying to have to set the whole thing up, but I think that really minimizes our chances of making mistakes. Part 2, at least you don't have to simplify the whole thing, so just be thankful for that. So let's move on to number 6. We have the first 3 terms of a geometric sequence are 0.64, 1.6, and 4. So the first question, thankfully, is finding the value of the common ratio. So how do we find the common ratio? I always find the common ratio by doing the second term divided by the first term. So we have 1.6 over 0.64 divided by 0.64. I'm typing that in the calculator. That gives me 2.5. I'm going to double check just because I don't trust myself to type things in the calculators to see if that works. So I'm going to try 1.6, which is our second term, times the common ratio and see if I get our third term of 4. And I did, so I'm feeling pretty good that my answer is correct. This next one says find the value of S6, which is the sum of the first 6 numbers. Just as a reminder, we haven't used this one yet. This is our first geometric sequence. I'm going to use the formula, which is U1 r to the n minus 1 over r minus 1, which should be good. All right, let's fill in what we know. So I'm going to use blue again. We have U1, which is 0.64 times r, which is 2.5 to the n. I'm looking for the sum of the first 6 terms, minus 1, over r, which is, I already forgot, 2.5. We found it in the first one, minus 1. Good. So bit by bit, I'm going to set up a bar in my calculator like that. So my numerator is 0.64 times 2.5 to the 6th power minus 1 over 2.5 minus 1. Most important thing, you can't even see that, can you? I put a parentheses after my 0.64 before I multiplied all this, and that's because I want the 0.64 to be distributed between both terms. Here, it did not matter if I put my 2.5 in parentheses because it's not negative, so it really doesn't make a difference. I wrote it on the paper anyway just because it helps me to keep track. But with that, I got an answer of 103.74, which seems mildly reasonable to me, so we're going to go with it. Good. Now I have find the least value of n such that the sum of n is greater than 75,000. So for this one, you need a calculator. If you don't have a calculator at home, that's fine. I'm going to do it right now. So I'm going to write down how I set it up on my paper so that we can go forward. So once again, I'm looking for the value of n such that the sum is greater than 75,000. So that means I'm using this formula right here. So I'm going to take 0.64 times 2.5 to the, am I going to take it to the 6th? No, because I don't know what the value of n is going to be. So I'm going to put that in as my x, remember? Because the calculator doesn't recognize n, but we want to keep that x flexible so that we can find the value of x such that the sum is greater than 75,000. Minus 1 over 2.5 minus 1. So I'm going to go over to my graph. And I was doing something else in here, so let me just clear that really quick. I hit tab, don't I? One would think. Okay, good. And clear this one. And I'm going to type in what I need to do. So I have 0.64. I'm actually going to start with the calculator bar. 0.64 times 2.5 to the x minus 1 over 2.5 minus 1, I think. Yep. Good. So that gives me this exponential looking function, which is good because we know that geometric sequences are exponential. I'm going to bring up my table, which I know you guys can't really see, so I'm going to try and make it better. Good. I'm just going to keep scrolling until I get to, what, 75,000? Oh gosh, I have to look down. Not quite there yet. Good. I think this is the first one, right? 158,945. So n equals 14. That's the least value of n such that the sum is greater than 75,000 because my sum is now 158,945, yikes, as opposed to 63,577. So we want to focus on this one where n equals 14. So I'm going to leave that circled. Good. Next one. So we have in a geometric series, u1 equals 1 over 81 and u4 equals 1/3. Once again, there's multiple ways we can do this. So I have 1 over 81. This is my first term. We don't know the second term. We don't know the third term. But the fourth term is 1/3. So if I'm thinking about how to solve this, I know that taking the first term times my common ratio gives me the second term. Doing my second term times the common ratio gives me the third term. And the third term times the common ratio gives me the fourth term. So if I were someone who is algebraically inclined, and luckily I am, I have 1 over 81 times how many r's? R times r times r times r to the third power equals 1/3. How do I get rid of 1 over 81? I had this discussion today with a couple of people. You can divide by 1 over 81. That gets really funky for me. So I'm just going to multiply both sides by 81 because here you see we can cancel this numerator with our denominator, and that just leaves me with r cubed equals 1/3 times 81, or 81 divided by 3, which we know is, actually I almost said that was 9, but that is not true, is it? So I'm going to go back to my calculator because I don't feel like doing some math in my head. 81 divided by 3 is 27. Good. Good, so now I take the cube root of both sides. R equals the cube root of 27, which I'll just show you how to do that in your calculator in case we forgot, but it's going to be 3. Plot twist. We're going to do control and then the caret, and I'm going to type in the third root of 27, and that gives me 3. Good. Glad to know that I am on top of my math today. Watch me roar. So we have r equals 3, and that was what we were looking for. Good. So find the smallest value of n for which Sn is greater than 40. So we're going to do the exact same thing we did up here, except with our new numbers. So let's see. My u1 was 1 over 81 times my common ratio was 3. Yeah, I guess so. Man. Okay. So common ratio of 3 to the n power, which we're going to leave as x, right? Because we want to keep that part flexible, minus 1 over 3 minus 1, which I think I filled that in right. I very well could not have. So once again, please call me out if I made a mistake. So I'm going to get rid of my table, and then I'm going to go back into my equation and delete that so that I can put in the new one. So I have, setting up my fraction bar here, I'm going to set up another fraction bar just because I know I'm going to have trouble, 1 over 81 times 3 to the x power minus 1 over 3 minus 1, which is 2. So I'm just going to write 2. I know I'm waving the calculator around a lot. I'm sorry. That's my fault. Okay, good. So 1 over 81 times 3 to the x minus 1 over 2. Good. So I'm going to go back to my table. And I'm looking for the smallest value of n for which Sn is greater than 40. I don't know if you guys can see that. I'm going to try and angle it. That's actually 8, which I know seems kind of crazy, but it's because we're multiplying by 3 each time, right? So once again, this is exponential. It's going to get real big real fast. So the least value of n for that such that the sum is greater than 40 is when n equals 8, because when n equals 8, the sum equals 40.49. Good, we're almost there. Oh, there's a backside. That's the worst. Okay, so let's keep going. We have in an arithmetic sequence, the first term is 8 and the second term is 5. So we are once again back to an arithmetic sequence. So, you're good, don't worry. The first term is 8 and the second term is 5. So what's the common difference? We take 5 minus 8, or I can just look and see that I want to subtract 3. So we know that my common difference is going to be negative 3. Good. Now we're moving on to the 10th term. Good. So we're going to move on to the 10th term, which we will be using a formula for in case we forgot in the 2 seconds. Well, it's probably been like 10 minutes. I don't actually want to look at how long this video is. U1 plus n minus 1 times d. I'm going to fill that in. So we have, I just dropped a pen. Oh, just kidding. It was just a piece of plastic. That's okay. All right, so we have our first term is 8 plus n, which is going to be 10 because we're looking for the 10th term, minus 1 times my common difference of negative 3 because it's going down. Make sure we don't drop that negative. So we have, I have to go back to calculate, 8 plus 10 minus 1 is 9 times the negative 3. That gives me a negative 19. So if I was writing this all official, like a good math scholar, that would be the 10th term equals negative 19. Perfect. Next one, sum of the first 10 terms, in case we forgot the formula, which I did, n over 2 times 2u1 plus n minus 1 times d. Let's fill this one in together as well. So we have the 10th term times 2 times the first term, which is 8, plus n, which again is 10, minus 1 times the common difference of negative 3. This is low-key going to take me a minute to type into my calculator, but that's okay. So we have 5 times 2 times 18 is 36, plus 9 times the negative 3 is a negative 27. I just accidentally typed in the trig button, which is not what we want right now. And I got 45. That doesn't seem right to me, so I'm going to think about that for a second. So we have 10 over 2, which is 5, times 2 times 18, which is 36, plus 10 minus 1 is 9, times a negative 3. How the heck is that? I guess, oh yeah. 2 times 8. 2 times 8 is 16. That would be it. This is why, again, why am I still combining in my head? I don't really know. That's negative 55. That seems more right to me because, more correct? I don't know. Because it keeps going down, right? So we're going to end up with a negative number pretty quick because we're subtracting 3 each time and the second term is already 5. So we end up with a negative 55. So we have 5 times 16 minus 20. Yep, there we go. that should be negative 55. So once again, if I was writing this correctly, it would be S10 equals negative 55. I'm actually going to stop the video now because I think this is scarily long. We're going to break it up into the next section. So I will see you guys later. Good job bearing with me until this point. And I'm going to find the remote to turn it off. So you're just going to have to hear me talk for a couple more seconds. There we go.